Now we're going to take notes on writing the recursive formula. So what we're going to do is, a second ago we used the recursive formula and we created the sequence. Okay, we either created the arithmetic or the geometric sequence. Now we're going to take this sequence and create the recursive formula. Okay, so the first thing you have to do is you have to determine if the sequence is arithmetic or geometric. Okay, if you can find a common difference. The common difference is if you're adding or subtracting by a constant, okay, every single time it's going to be an arithmetic sequence. If you have to find the ratio, that's a common ratio, we're going to be writing a geometric sequence or equation, okay? Well, how do you find those equations? Well, once you've determined if it's arithmetic, we're going to use the nth term arithmetic sequence that we came up with. All right, which is a to the n equals an minus 1 plus d. Well, at this point, you would just plug in the common difference that you've already found because d is the common difference, and that's the only thing you would plug in or substitute, and your equation is done. If you cannot find the common difference and you find the common ratio, that means we are going to write a geometric sequence where we just apply the R, common ratio, up front. Okay? Step 3 is it says state the first term, what I needed to add in there, then equation, and the domain for n. Okay? So it's going to be 3 parts to this recursive formula. Here we go. Example 1. It says write a recursive formula for the sequence 4, 10, 25, 6.2, and or 62.5. Step 1, subtract each term from the term in front. All right. When we're used to doing loops, y'all, if you go from 4 to 6, it's 4 to 10, it's what?
6.
Okay. But you're actually mathematically you're writing it like this, which gives you a positive 6. You're taking this term, you're subtracting it from here. Okay. So now we're going to take 25 minus 10, which gives us, and then we're going to take 62.5 minus 25, and that gives us 37.5. Do I have a common difference? No. Okay, so we're just going to write no common difference. Check common ratio. Okay. If there's not a common difference, we have to check the ratio, okay, to see if there is a common ratio. To check a ratio now, we're going to take this term on the right. It's going to be my numerator, and I'm putting it over the term on the left, correct? So it'd be 10 over 4, 25 over 10, 62.5 over 25. Okay, so we're fixing to write those out. All right, so if you have 10 over 4, what do you get? 2.5. 25 over 10 gives you what? And then 62.5 over 25 gives you 2.5. Step 2. Since we found a common ratio, what kind of sequence are we now going to create? Geometric. Okay? So I know I have to use geometric. The equation for the nth term of a geometric sequence is an equals r times an minus 1. Because I have to use the nth term for a geometric sequence. Well, I know that r is my common ratio, and it equals 2.5 for this sequence. Agreed? So how do you write your equation? You just fill in what you know. an equals 2.5, that's my common ratio, times an minus 1. That's it. That's how you create your equation. Okay, in step 3, we're going to write the domain for n. Well, the domain for n is always n is greater than or equal to 2. Okay, so what we're going to do is we're going to write each of these in the steps that you belong. So we're actually writing the entire recursive formula. So you say the first term, a1 is 4, because the sequence started with 4. I now write this equation, an equals 2.5 an minus 1, comma, and I always finish it if n is greater than or equal to 2. And you just wrote your first recursive formula. It looks complicated, but it's not near as complicated as what it looks, okay? One more. Write a recursive formula for the sequence 25, 35, 45, 55. Right then, what do you notice about the sequence?
5.
Yes, it adds what? It's adding 10 every single time. So mathematically, let me just show you how to prove it mathematically, is you would just say 35 minus 25 equals 10. 45 minus 35 equals 10. And 55 minus 45 equals 10. Okay, so that says, what is this 10 called?
Common difference.
The common difference. So I have a common difference, and that common difference is 10. Okay, so if I have a common difference, what kind of equation are we going to now write? Arithmetic. Okay, so step 2, since I have a common difference, we're going to find the arithmetic nth term equation, which is an equals an minus 1 plus d. We know that d is a common difference. Which is what value? What's my common difference? 10. So all we're going to do is we're going to plug in the value of d into the equation. So we're going to say an equals an minus 1 plus 10. Now what if my common difference was a negative 5? Can that happen? Yes. So would I put plus negative 5?
No,
I would just write minus 5. All right. Now, step 3. So this breaks it down a little bit more than the last example. My first term, a1, was 25. The recursive formula is an equals an minus 1 plus 10. I got that from right there. And the domain for n is always what?
N is greater than or equal to 2.
And all we're going to do is we're going to put this together with commas. So you're going to say a1 equals 25, comma, an equals an minus 1 plus 10, comma, if n is greater than or equal to 2. I don't know why I keep putting an extra line there. And this is the recursive formula for the sequence given to you.